Okay, this is a comedy of errors, but apparently this new hotel I'm in, the Wi-Fi speed is not sufficient to allow me to do streaming. So I'm not going to stream. I'm going to record and upload, and hopefully that goes well. And it's late, so I won't get on the leaderboard. And I'm using my work computer, which means that it's not my same setup, and hopefully it works. But I think I've got it set up the way I want it to. And yes, so now let's go look at the problem. I'm sort of not having the best streaming day, but that's okay. And I'm on a Mac, and I don't like Macs, so that itself is a challenge. You're starting to sweat as the ship makes its way towards Mercury. They also suggest the air conditioner working by upgrading your ship computer to support the Thermal Environment Supervision Terminal. Thermal Environment Supervision Terminal starts by running a diagnostic program. It will run on your existing Intcode computer for a few modifications. First, you'll add two new instructions. Takes a single integer as input and saves it to the address given by its only parameter. For example, the instruction 350 outputs the value. For it would output the value. Will come with documentation explains what should be connected to the input. Program 3040 outputs whatever gets as input, then halts. Second, you need support for parameter modes. Each parameter instruction is handled based on its parameter mode. Right now, your ship computer already understands parameter mode 0 position mode, which calls the parameter to be entered as a position. The parameter is 50, blah, blah, blah. So, mode 1, immediate mode. In immediate mode, a parameter is simply interpreted as value. 50 parameter modes store the same value. Opcode, the opcode is a huge number. It's only the ones and 10 digits of the value that opcode is driven as 2 digits. Parameter modes are single digits, one per parameter. Red, left, right for the opcode. The first parameter is mode is 100 digits. Second parameter is mode 1,000 digits. Third, 10,000 digits. So any missing modes are 0. The first instruction is a multiply instruction. The right must 2 digits to indicate opcode 2 multiplication. Then going right to left, the parameter modes are 0, 1, and 0. This instruction multiplies its first two parameters. First parameter 4, so you did its value, blah, blah, blah. Parameters instruction writes to will never be in immediate mode. Finally, so note it's important to remember the instruction pointer should increase by the number of values in the instruction after the instruction finishes. Because of the new instructions, this amount is no longer always 4. Integers can be negative. The test diagnostic program will start by requesting from the user the ID of the system to test for any. Okay, so I hope this is recording. Because if it's not, I'm in trouble, and I'm doing this for nothing else. Anyway, it wants me to use the computer from day 2, so I'll start with that, although I'm not that happy with how that computer worked, so I'm going to start by modifying it. We're still going to say a program is a list of ints, but now what we're going to say is we're going to say start using name tuples here. Name tuple. So instruction name tuple, and that has an opcode, which is an int, and it has a damn it, why do I keep doing that? It has a program 1002434333. The first instruction is a multiply instruction. That's why I address 433. The second parameter 3 simply has value 3. The result of this operation is 99. Parameters instruction write to will never be in immediate mode. So parameter modes are stored in the same value instructions opcode. Let's get this, and let's say arguments is a list of int, and so first what we need to do is we need to parse opcode int, and it is going to get some parameter modes. Parameter modes is a list of ints, and then arguments is a list of ints. So parse opcode. And it's just going to return a tuple of an int and a list of ints. So let's see how this works. Opcode is a 2-digit number based only the ones and tens digit. So what I need to do is opcode part equals opcode, mod 100. That will be that part, and then going right to left, the parameter modes are 0 100th digit, 1000th digit, and 0 10,000th digit. So, and is that the order I wanted in? The first. Read right to left from the opcode. And so we want hundreds digit equals how do I get the hundreds digits? I get the hundreds digit by saying divide by 100 and then mod 10 equals opcode divided by 100 mod 10 thousands digit equals opcode divided by 1,000 mod 10 and 10,000th digit equals opcode divided by 10,000 mod 10, and I want to return opcode part and then hundreds digit, thousands digit, and 10,000s digit. So let me just make sure that this works. I need this. Okay, so that seems to work pretty good. Now let's go back. So that's fine. Parameters of instruction writes to will never be, and then any missing modes are 0. So 1 is immediate mode and 0 is position mode. So let's say 1 is immediate mode, 0 is position mode. Okay. Program is a list of ints, and I'm actually going to just get this def run program, and now I'm going to do it this way, which is the way I should have done it last time. Like I said, program equals, so I'll just make a copy of the program so that I'm not clobbering it, and I'll say my position is at 0, and while the program position, and let's, while program, okay, opcode and what did I call it? Modes equals parse opcode program pos. And now if opcode equals 1, and so now if opcode equals 1, I want to do that, but it's possible that I don't want to do the location. So, okay, so let's say value 1 equals program pause plus 1. So that's the location. And so if mode 0 equals 0, else program pos plus 1. So if and then similarly, value 2 equals this plus 2. If modes 1 equals 0, else program pos plus 2. And then what I want to do is I think it said that has to be, the third one has to be the position mode because it's going to, actually no. What did it say? Increased by the number of values in the instruction. This is no longer 4. Integers can be negative. That's fine. Test will return output. It's written according to third parameter. Parameters that an instruction writes to will never be in immediate mode. Right. So that was what I was looking for. So now program pos plus 3 equals value 1 plus value 2, and then pos plus equals 4. Okay, so that's add. Otherwise, if opcode equals 2, that's multiply, right? And we can basically multiply, and this logic should be the same except for the times. So that's good. And then now it wants me to add some new opcodes. Opcode 3 takes a single integer as input and saves it to the address given by its only parameter. For example, the would take an input value and store it at address 50. So takes a single integer as input and saves it to the address given by its only parameter. The instruction 350 would take an input value. What, I don't know what that means, takes an input value. Takes a single integer as input. So I don't, what is an input? You come with documentation that explains what should be connected to the input and output. The program 304 outputs whatever it gets as input and then halts. Okay, so I'm not really following this. Parameter Parameter modes are stored in the same value structure as opcode, the output cheat number, but what is that? Yeah, we got the opcode part. Order test right now. System will start by requesting from the user the ID of the system to test by running an input instruction, provided one. It will then perform a series of diagnostic tests that a bunch of stuff programs correctly. And for each test, it will run an output instruction indicating how far. Check the instruction. Sorry, I'm having a lot of trouble understanding this. The test diagnostic system will start by requesting from the user the Let me look at the input. So here's a program that wants me to do some stuff. And each parameter is handled. Opcode 3 takes a single integer as input and saves it to the address. For example, the instruction 350 would take an input value and store it at address 50. Opcode 4 outputs the value, would output. Programs that use these instructions will come with documentation what should be connected to the input and outputs. What should be connected? I'm just not getting this. The test diagnostic program will start by requesting from the user the ID of the system to test by any input instruction, provided one. It will then perform a series of diagnostic tests confirming that various parts of the input computer, like parameters, function correctly. For each test, it will run an output instruction indicating how far the result of the test was from the expected value, where 0 means the test was successful. Non-zero outputs mean a function is not working correctly. Check the instructions that were run before the output instruction to see which one failed. Finally, the program will output a diagnostic code and immediately halt. This final output isn't an error. An output followed immediately by a halt means the program finished. If all outputs were 0 except the diagnostic code, the diagnostic program ran successfully. Okay, input is a list of ints, and instead it's going to return, let's also say, a list of ints, and output equals this. So I still don't really understand this, but let's say if opcode equals 3, get input and store. Takes a single integer as input, and saves it to the address given by its only parameter. So at location, loc equals program pos plus 1, input value equals input 0, input equals input. I don't know if that's how input's supposed to work. Like it's not clear to me, but it's a list. I'll pop off the front one, I guess. And then program loc equals input value, and then pos plus equals 2. elif opcode equals 4, get output from location. So again, outputs the value. Instruction 452 would output the value at, so it seems like that can't be immediate either. Location equals program pos plus 1. Output dot append program loc, and then pos plus equals 2, and then elif opcode equals 99, and 99 I think was the halt one, right? Return output, and then else raise invalid opcode. And so I think that's what we were supposed to do. While program pause is not equal to 99, and so I don't need to do that. I'll just do that out here. They don't give me any, well, so cd day 05, run day 05.py, and let's say run program with 1 as its input, and it produces 1 as output, 20 as input, 20 as output. So that's doing, it looks like what it's supposed to do. So the test diagnostic program will start by requesting an input instruction, provided 1, will then perform a series of diagnostic tests confirming that various parts of the encoded computer like parameter modes function correctly. For each test, it will run an output instruction indicating how far the result of the test was from the expected value, where 0 means the test was successful, and 0 output means check the instructions and see which one failed. Finally, the program will output a diagnostic code and immediately halt. This final output is an error. If all outputs, so I don't quite, okay, so here's the big program. And so I want to run a program, and I'm supposed to give it 1 as input, and it spits out a 3, which is bad. Why does it spit out a 3? It spits out a 3 because okay. Well, let's do this. Let's do print opcode and modes, and let's do it again. Three 0 0 0, and 3 is read the input, I guess. And if opcode equals 4, print loc program loc So it's really the first one that's gone awry. And why has it gone awry? It's gone awry because opcode modes, program pos plus 1, program pos plus 2. Print. So the first few instructions are what's going wrong. So it's saying stick this at 225, add to what's at 225 and what's at 6, and stick it in 6. So boy, that's going to be a mess, but let's try it. Okay, so that's no good. Well, let's do print opcode and modes. Print adding value 1 and value 2 and sticking the result at program pos plus 3. And let me and this will be multiplying. Okay, adding 1 and 1100, sticking the result at 6, adding 1 and 238, sticking the result at 225. For so what am I doing wrong that I'm not getting all the zeros it wants me to? So I read the input. Now I add 100, stick the result at 6. Opcode equals 4. Then let's look at the program. All right. Okay. Okay. So I'm going to have to make this super verbose, unfortunately. So if mode 0 equals 0, value 1 equals print loc1 is program pos plus 1. So value 1 is value 1. Else value 1 equals program pos plus 1. Print f value 1 is immediate value 1. Now I'm going to have to do this. If modes 1 equals 0, value 2 equals program pos plus 2, and print loc2 is program pos plus 2. So value 2 is value 2. Otherwise, value 2 equals program pos plus 2. So we can do value 2 is immediate value 2. And then I can do this. And now let's copy this and put it in the multiplication part too. And comment this out. Okay, so lock 1 is 225, so value 1 is 1. Lock 2 is 6, and so value 2 is 1100. Adding 1 and 1100 and sticking the result at 6. Value 1 is immediate 1. Value 2 is immediate 238. So that's let me do this. So I'm at position 0, I read in 3, then I'm at position 1, I get that. Then I'm at 3, 4, 5, 6. So that's 1101. So 1101 is another add. So I'm going to, but now it's both in immediate mode. So I get 239 and I stick that way out in the future. And now I get 104. 104 is output. Oh, I guess output can be immediate. So if, yeah, output can be immediate, that must be the problem. So if, what am I calling it? Mode 0 equals 0. So that's indirect. Value equals program loc. Otherwise, value equals program pos plus 1. And then I can do output.append value. And now let's run it. I think that's maybe the issue. Yeah, that's the issue. So then let's copy this and paste it in. That's the right answer. Comes back on the line, followed. So you'll need to use the test to extend thermal radiators. First is already equipped for this. Unfortunately, our code here is not. So a few opcodes. Opcode 5 is jump if true. If the first parameter is non-zero, it sets the instruction pointer to the value from the second parameter. Otherwise, it does nothing. Opcode 8 is equals. Like all instructions, these instructions need to support parameter modes described above. Normally, however, if the instruction modifies the FIUZ instruction pointer is not automatically increased. For example, blah, blah, blah. Okay, so we need to add more opcodes. So this is not very exciting, but okay. Elif opcode equals 5. This is jump if true. If the first parameter is non-zero, it sets the instruction pointer to the value from the second parameter. Otherwise, it does nothing. And these all need to respect parameter modes. So, so let's say value 1. We can just get the same logic and copy it and then refactor later. If the first parameter is non-zero, and so if value 1 is not equal to 0, it sets the instruction pointer to the value from the second parameter, otherwise it does nothing. Pause equals value 2, and then increase the value. If the instruction modifies that value is not automatically increased. So otherwise we have to this is otherwise pause plus equals 3, I guess, because we did that. Opcode 6 is jump if false. If opcode equals 6, and then and I'll just copy all this. First parameter is 0. It sets the instruction pointer to the value from the second parameter. Code 7 is less than. If the first parameter is less than, it stores 1 in the position given by the third parameter. Otherwise, it stores 0. And then opcode 8 is equals. So elif opcode equals 7. This is less than. I'm just going to copy the add because that seems right. If value 1 is less than value 2. Stores 1 in the position given by the third parameter, otherwise it stores 0. Equals 1, else equals 0, pos plus equals 4. And then opcode 8 is equals. If it's equal, it stores 1, otherwise it stores 0. So let me just copy this again. If opcode equals 8 equals, if value 1 equals value 2, it stores 1, otherwise it stores 0. And then otherwise it's an invalid instruction. And test diagrams provided 5. This only outputs one number, the diagnostic code. What is the diagnostic code for system ID 5? So now I want to well, let's see if that's right. If it's not right, then we have some real problems. That is the right answer. Okay, well, that kind of, yeah, I did not enjoy that problem very much. But anyway, let me stop recording and remux and see if I can upload it. All right, thanks for watching.